download page and download the appropriate latest for your operating system. So for example, you click on Arduino 1.0.5 and then you would select Windows or Mac or Linux. I don't think anyone's running Linux. Is anybody running Linux? You should look it up. If you run Linux, you're cooler than the rest. Just kidding. You're like, no, you're not. You're actually tortured. That's why we all have Linux on something that we own. Okay, so Ray, you've got Linux on something you own too, right? Yeah. So anyway, is that going? Okay, awesome. So while this is downloading, we're going to start talking about kind of the general interface and how it looks with this wonderful picture that I have, because it's not letting me download anything. So this is called an Arduino sketch. It's just what they call the Arduino files that you code in. And generally what you have is your verify button, your upload button. Oh, I forgot about that. New file, open, save, close, that sort of fun. And then this over here, which is incredibly important, is your serial monitor, and it's this little magnifying glass. That's how you're going to get to that, and we're going to go over that in a little bit. So we have different how many people have programmed in here? So what have you guys programmed? What language? Java?
Java.
No, Arduino and Java.
Why?
How about you guys?
C++ and Robot C and a little bit of Java.
Awesome. So who knows what language Arduino is based off of? Yeah, somebody answer.
C++.
C++. Has anyone done any processing? No? Processing is just a flavor of Java. And the reason I bring that up is Arduino and processing are both open source software. And so Arduino actually uses the exact same development environment as processing. So it's just interesting because they use the same stuff. People often think they're based off of the same language, and they're not. Arduino is C++, processing is Java. You might find libraries for processing, they will not work for Arduino. Vice versa, same applies. So, why do we need this? Does anybody know? Big yes? I know it's a very big general question.
Different file words you can write the code just send to our microcontroller.
Right, and why do we need something that compiles?
Because how else are you going to tell the microcontroller what to do?
Right, because the microcontroller isn't talking in this language, right? And so the compiler takes care of it for us. It's called high-level language. The compiler turns it into machine language so that the microcontroller can understand what we're talking about, right? But this makes it a lot easier for us so that we don't have to code in like zeros and ones and all that other stuff, right? Assembly is just a lot harder. If you've done any assembly, I know he probably has, I have not. That means you're even cooler. So than if you have Linux. So has anybody done any assembly in here? No? Okay. There's a reason for that. So this makes it a lot easier. Arduino is just a really nice package. It's small. You can use it in a lot of projects. Obviously, that's why all of you guys are using it most likely in most of your projects. So, who can tell me, so let's talk about variables. How many people have dealt with variables? All the people have coded, right? What's a variable?
It's something that holds like a piece of information. It's like an int or a char.
Right, so we're dealing with two different things here, right? We have a data type, and then we have the variable. The data type helps the variable out. So a good way to think about variables is how big is this container that you need, and what type of container is it, right? So what are some of the reasons why we might use variables in coding? Anybody? If it's storing a piece of information and we declare it once. Yeah, Desi?
If you want to use the piece of information throughout the code and you don't have to change it, you can just change the variable as opposed to going through the code and changing it every time.
Exactly, because coders are inherently lazy, and you know what, we should be. Because why would we make ourselves do more work than we have to? So we have a lot of shorthand, right, and different ways to do anything. What are some of the other reasons why we might use variables?
To store information that you know is going to be changed every time.
Exactly, and why would that matter?
Because like usually you start out with something that you're inputting, and then your output's going to be way different.
Right, and you can't keep track of it, right?
Yeah.
That's why you're writing code to deal with it,
Yeah.
right? And it's going to change, and that way you don't have to know that 13 is still 13, or if it changed to 7 or whatever by the end of the code, right? And we can still refer to it, change it, update it, and do what we need to do. There's one more reason why we use variables. Anybody? Think about just two numbers, right? If you have two of the same number, how might that be a problem if you didn't have a variable?
Oh, differentiate between.
Yeah.
Exactly, so you could have two number 13s, right, at one point in the code and you don't have to worry about it, right? Right. So, in order to kind of determine what kind of box we're putting it into, right, we use data types. And some of those data types are like int for integer, char for character, float is for floating decimal point, right? Why would we need to tell it what kind of data type? Yeah.
Like the amount of space it needs to have and that's stored.
Exactly, we need to know how big this box or container is that we're storing this information in. Anything else? Yeah.
Well, don't each of them have like different what different storage sizes is?
Right.
So like
So
an int is smaller than a float.
right.
Okay.
So different storage sizes, but there's also another reason.
Manipulation. You can't like I don't know.
Yeah, no, that's on the right
Buy a
track.
string, buy it in, because it makes sense.
Right.
That's helpful.
Right, it has to know what type it is, right? Like a character, like a letter in the alphabet, right, is totally different than the number 30, right? Or 370, whatever, right? Completely different. And so it has to know what kind of data it's dealing with so that it can perform different operations. Now there are exceptions to that, but for the sake of this, we're going to pretend there aren't exceptions to that. So how do we define a variable? We just kind of was talking about it. Yes.
You say blank equals blank.
That's assigning. So how do we define it? I was just talking about it. So it'd be really easy. Yeah, data type, right? So we define our variable, right? Because we don't need to necessarily assign values to it at the beginning. We can assign later. But we can declare them at the top so that everybody has access to the same variables. You'll often, somebody got this error in the AM class, which was that it couldn't find the variable even though they had defined it. But they had defined it in a part of the code that the rest of the code couldn't see. So it's a really good practice to define variables once, right? So you do, for example, int LED, right? And then I would never declare it again throughout my code. That's bad practice, right? Because why do we need to declare the same thing twice? We don't. So to assign it, we put it equal to something, and that can happen at any time in the code, but we want it to be defined at the beginning. So also, there are comments. Can somebody tell me the difference between this type of comment and this type of comment? Desi?
The 2 slashes are only 1 line, and the slash with the asterisk can be as long as you want.
Exactly. Why do we need to comment our code?
So other people you're working with can follow it going wrong.
Exactly. Other people can follow it and you can follow it. Yeah. Because you have no idea how many times you come back to something and you're like, what was I thinking? Why did I do that? I don't know. But it could be really important, right? Like you could have found something out and you're having trouble, you're getting an error, and you needed this one line of code to fix it. But you don't remember that 5 months later, and then you delete it, and then you crack. Because you're like, I'm getting the same error again. How did I fix this last time? So, does anybody know what a function is?
It's a section of your code that you can like reference, and it'll do the same thing. It'll take a specific input usually, and then it'll like either do something or like have an output that it returns. I don't know what.
So I like to think about code as you're writing a letter to the computer, okay? Or whatever you're trying to program. You're writing a letter to it. And you might be like, well, that's really corny. And yes, it is, but it's really very applicable, to be honest. So usually you declare your variables up at the top, right? And you think about that like if you're writing a formal business letter, right? That's like, hey computer, this is my information, right? Like those are the addresses, your to and your from address. How many people know how to write a formal letter in here? Or you vaguely remember it maybe from class at some point in your life. Okay, good, everybody. That's what I was getting at. You put addresses at the top, right? And you want to tell it like where you're getting information from, right? What your data is. Then you say, hi computer, I'm ready to start, right? And you do that once, and it's usually like your introduction. And so often, not in every language, and you don't always have to do it, but there's often like a main function called setup. And that allows you to kind of say, hey, this is what I'm doing, now let's do it. When you get to the second main function, like loop, that kind of is like the main part of your letter. This is what you're trying to accomplish. It's the meat and potatoes of your letter, right? And functions are like paragraphs. And within that paragraph, you have many different thoughts or statements. And each thought or statement is like a sentence, and it ends with a semicolon instead of a period. And so a good way to think about functions is they can return things, right? And if they do return things, you have to tell it what you want it to return with a data type. And if you don't, then we put void, because that means I am not returning anything, I'm just doing this over and over again. Who can tell me the difference between the two main functions of setup and loop? Graham.
Setup happens once and loop keeps happening afterwards.
It loops, right? Forever into infinity until it stops, right? Or you run out of memory, right? Awesome. Okay, and then one other thing, and then I'm going to start going into Arduino specific stuff. So who can kind of tell me the difference between syntax errors and logical errors? Dan.
Syntax error is just like you've written the wrong thing, like, you know, you wrote,
Give me an example of like some kind of syntax or like a very specific one that might help.
okay, I guess you write function right 13 high, the syntax error doesn't exist, or you
Maybe you forgot something, right? What do people usually forget? Semicolons.
yeah, I forgot your semicolon, or maybe like you say digital write to a variable which you didn't declare, something like that.
Exactly.
Logical errors, it just doesn't make sense, like what you wrote, it just can't happen.
Right, and so often with logical errors, right, the computer doesn't necessarily catch them, right? Like you could have written an equation and it might be giving you a number, but it might not be the number that you were expecting to get because you did your equation incorrectly, right? Or maybe you compared something that really can't be compared, and sometimes it'll throw an error and sometimes it won't. So syntax is, I forgot like semicolon, I messed
Right.
something up and the computer can tell what's going on, whereas with logical errors, you're kind of on your own and you made that mistake. Right? So, yep.
What's an example of a logical error?
So an example of a logical error is sometimes something that a lot of people do would be they assign their variable a new number, for example, instead of comparing it. So if you compare something, it's 2 equal signs, and if you assign it, it's 1 equal sign. And so they think they're comparing it, but really it's always true, for example, because they assigned it instead of compared it. So did that make sense?
Yeah.
There are so many different types of logical errors. That's probably the most common though. Because as far as the computer is concerned, it's correct.
Right. Could a logical error also be like LED minus LED 1 or equals, or not equals, like LED minus LED 1 when it's really supposed to be LED minus LED 2. Could that be
Yeah. I mean, pretty much it's if you made a mistake, right? And it's not something that necessarily is incorrect. It just doesn't work.
Right.
So one other thing to point out is, as you can see here, when a word is recognized and it's the correct syntax, it will usually show up a different color, right? Because this is an integrated development environment, which is what ID stands for, right? And so it's this really nice place for us to code in. Because if, for example, I put a capital P there, it wouldn't turn orange. So it would also throw an error saying it doesn't recognize pin mode, for example. And that's because you capitalized the P, you missed it, and the computer's like, I don't know what that is, you just totally messed me up, right? I'm not gonna do this. So, just good to kind of look at that, especially when if you're just starting coding, to look at if it changes colors or not, okay? Any questions about any of that? Everybody's like, I'm already an awesome coder. Now we get to the fun part, which is hooking up the Arduino. And there it is. So this is an Arduino. Yay, right? You guys, there's many different flavors, right? What kind of flavor of Arduino are you working with?
Really bad.
Are you working with Arduino? Yeah, I think
Uno.
you are. Uno? Anybody else? Yeah?
Mega?
Mega?
Micro? I'm gonna be working with Arduino.
See, everybody's got a different flavor, right? Same basic gist, though. We're all delicious. What
Oh,
was
is it? I thought that was like something. No.
I've got an Uno right now, but it's all generally the same. So you plug it in, what do you know, there's an LED. So, I put my code in. It's a really good idea to actually follow along if you're not familiar with coding or this particular brand of coding. And pretty much retype it. Have one sketch open with the example and then one sketch where you copy it yourself and type it. Don't copy and paste everything. So the way that you get to this is if you go to, click on your Arduino, go to File, go to Examples, and then go to Basics, you'll see a blink sketch. And if you click on that, it'll pretty much open up something very similar to this. Is everybody doing that? You got blink open? You all in?
Yeah.
I see a lot of errors.
I just couldn't. I forgot I
Oh,
didn't
0,
do
4.
it.
Cool. Awesome. You guys all good? No, I just wanted to know from the That's okay, just follow.
Just take the link and just go download Arduino.
noted, right, everybody's working with a different type of board, which means that it needs to compile a little bit differently for each and every one of you. How do you change that, right, to whatever board you're working with? Well, if you go up to Tools, and then go to Board, you can then select from a long list of whatever particular board you have. If you don't know what board you have, you should look it up, right? Look at it, it's usually silk screened on it, and then you can usually go to SparkFun or wherever you got it from if you're still having trouble finding the particular compiler for that board. You also want to make sure that your serial port is correct. You guys can't do this right now, but you can just kind of look at it. You really need to have an Arduino attached. I'm going to pass this around after the lecture and you guys can look at it and plug it in and play with it. So now that we have that out of the way, right, we can start getting to the code part. And for example, since this computer won't let me download anything, here is here's basically in the Blink sketch, right? And we're going to add 2 little lines to it. And the reason we're going to add 2 lines to it is so that we can see how far we get in our code. Yes?
Does the syntax change for each different board with Arduino?
No, just the compiler. So it's using all the same language, it's just
It
different
knows
compilers.
how to send it out.
Yeah, and it knows that by you selecting what type of board, and then it uses that flavored compiler. They're usually like really similar chips. They're just slightly different format, whatever. So, how many people know what debugging is?
When you like, I don't know what's going on in my code. Let me throw in a bunch of print statements with all my variables so I know what is happening and why it's not working.
Does anybody know why they're called bugs or debugging? Desi.
There was, I think it was in the Navy, one of their computers wasn't working and they went into it and they found a moth in the computer, so they wrote down in the book that they found that it was debugged because they pulled the moth out.
So bugs used to actually be bugs, right? And you'd have to clean them off, physically clean them off of your computer when the computer was in the entire room, right? So this is a really handy way to figure out what's going on in your microcontroller, what it's doing, and what you're doing. And so we're going to add this wonderful line, serial.begin. It's capital S, serial.begin. And the reason we're doing that is we're telling the computer, right, because we're in our setup function, telling the computer, I want you to open up the serial port, and I want you to listen at a particular rate. It changes for certain devices, but 9600 baud rate is kind of standard. So I'm just going to do 9600 and then parentheses, 9600 parentheses, right? Now, I've opened up the serial port and now I need to get something back from it, right? So to do that, I do serial, once again in capital S, dot print ln, parentheses, and then I say, I made an LED blink. In quotes, in parentheses, semicolon. So the curly braces kind of define where the function is, right, and where the paragraph is. So now, when I hook up my Arduino and I open up the serial port, if it gets to that point in the code, it'll say, I made an LED blink. And I'm going to show you guys that right now.
what is 96?
It's the baud rate, so it's like the rate that it's reading at. And so it'll go up to like some stupid number, I think the max is
The
like.
rate is read the code.
No, so the code is just read at a particular rate, but in order for us to communicate, right, we
Yeah.
need to send data and receive data, right?
Okay.
And so at what rate is it sending and receiving data, and that's the baud rate. Serial is actually a really old form of communication. Not super old, right, but older.
So then if you put like a 1 in mode, will we have to wait like 10 minutes to see the LED goes
It
high?
probably won't do anything,
Oh.
actually. It probably just won't read it, right? There's particular standardized rates, right, that we can. So for example, right, I have the LED and the Arduino hooked up, and I put this in, and basically every time it hits it in the code, it goes, I blink the LED, right? And to get to that serial monitor, I just hit the magnifying glass up in the upper right. I blinked it. Cool, you're like, I already did something. Okay. I'll show you guys later. Now we'll go through the code quickly, and then we'll get into it. So, we've gone through setup, we've gone through like setting up our variables, right? And so, who's gonna guess what pin mode does? Pin mode, LED, output. Take that thing.
So what the Arduino pins an input and output.
Right, we have to know whether we're sending or we're receiving data on that pin, right? Yeah. And then in digital loop, void loop, why would we have digital write? For the same reason, right? We want to know what type of signal it's using, and we want to tell it to do something. And since it's an output, we're writing to it instead of reading from it. So we're telling the LED, pin 13, to go to high and turn on. Then, what about delay? Yeah.
How many milliseconds before the next action or next line of code should be executed?
Right. So, one thing to keep in mind with delay is once you start a delay, it shuts down the microprocessor. So don't expect during your 5-second delay, for example, to be doing anything else. It pretty much just stops everything. Okay? So there's other ways to get around that, but it's just something to be conscious of. So, if we change delay, what's going to happen on this?
It's gonna blink much more.
Or slowly, right? Depending on what we do. So for example, what do we want to change it to? How long should it be on?
1,000.
Okay. So it's on for 5 seconds now, right? So now it'll be on for 1 second. So I upload it after I checked it, and then after it loads on, it'll be 1 second on, 1 second off, right? And if I change it to 200, what's going to happen? No, 200, not 2000.
Oh, much better.
Yeah.
It wasn't a trick question, I swear.